trigonometric functions always have a period. What does periodicity mean? The function is said to have a period if it can repeat itself at the same value. I'm not going to go over the entire unit circle, but good enough, assume that it's perfect. Going to assume that that is 45 degrees. That's the first. So I have 30 degrees, 45, and 60 degrees. And we came up with these values last time. So I can write sine 60 degrees, 30 as 5 over 6. And that value is equal to 2. You can also use your calculator. In a similar manner, sine 5 over 4. 1 plus 1 is 2. Sine 5 divided by 3, that should be 60 degrees. Square root of 3 over 2. I'm going to complete one full revolution in the sense, start here, go around and come back to that point. We know one full revolution is 360 degrees. It is the same as saying 2 pi in radius. And my question to you, I complete one full revolution, get back to pi over 6. What is the value for that? Colin's telling me 1/2. What?
Because you said trigonometric functions repeat over a period, and because sine can't be greater than 1, it has to be like 1/2 by that.
Okay, any other answers? It is correct, but slightly off in terms of explanation. It is not that it has to be less than 1, hence it has to be 1/2.
Like add some pi, that's like a whole revolution.
So if you go a full circle, and if you came back from 2 pi over to 30 degrees, it is the same value. Do you agree? If I got rid of that 2 pi, still sine 30. So that would be 1/2. If you took the common denominator and combined, so sine 13 pi over 6 would be equal to 1/2. But I want you to pick up your calculator. I want you to plug in 4 pi. And 10 pi. Tell me what the answer is. Even before you start them, can you make a guess as to what that harmony will be? No. Just guess. So it is going to be 1/2. Reason being, one revolution, 2 pi, another 4 pi, back to the same position, another 6 pi, back to the same position. Keep on going. How many revolutions did I make here? Here, 16 pi. 8 revolutions. So, 2, 4, 16. I want you to pick up your calculator. Give me an odd number between 2 and 10. 3. Okay, let's add 3 pi to pi over 6 and tell me what you get. Sine pi over 6 plus 3 pi. So if I plug in 3 pi, I'm not getting 1/2. Why?
Because it's 3 pi's in the middle of the revolution.
So it's in the middle of the revolution. In other words, you're not completing 2 full revolutions. You're doing 1 full revolution and just half of another. So it is not going to match up. So you've got to complete full revolutions. In general, sine of some angle t is equal to sine t plus 2n pi, where n is any whole number including 0. So no matter what n you put, as long as it's a whole number, you would have sine t equals sine t plus 2n pi. What is the value of n? There. 1, 2, 8. So n pretty much tells you the number of revolutions that you make after the first one. Okay, let's take cosine. What is cosine pi over 6? Square root of 3 divided by 2. I want you to find cosine pi over 6 plus 2 pi. So cosine pi over 6 plus 2 pi, cosine pi over 6 plus 4 pi, cosine pi over 6 plus 32 pi. And tell me what you get. Divided by 2. So no matter what you plug in, square root plus 3 divided by 2, square root plus 3 divided by 2, same, divided by 2. So in general, we have cosine t would equal cosine t plus 2n pi. Once again, n is a whole number, 0, 1, 2, and it keeps on going. Here's the question. And again, cannot be formed. So, excuse me. You can't have an odd number here. If you have pi, 3 pi, 5 pi, you're not going to get the same answer. So this setup where things repeat in 2 pi values is what we call 2 pi period. So sine, cosine, both of them are 2 pi periodic. In the sense it is going to repeat every 2 pi period. And that's just the general form, n equals 0, 1, 2, keep it on going, and it'll be the same value as cosine t. Are we clear?
Let's get you square root of 2 square root of 2.
What are the square roots of 2? I see what you're saying. Okay. So sine t divided by cosine t is tangent t. So I have sine and cosine here. 1 over square root of 2 divided by 1 over square root of 2 is 1. Or 30 degrees, 1/2 divided by square root of 3 over 2 is 1 over square root of 3. Square root of 3 over 2 divided by 1 over 2 is square root of 3. Using the same logic, we want to find tangent of pi over 2. What is the answer? You can use your calculator. So, what do you get? Should get an error. Why? Sine pi over 2 is 1. Cosine pi over 2 is 0. 1 over 0. Take note there. So, calculator, we call it undefined. Going to call it what it is. The reason being, well, tangent is right over t. That's a vertical asymptote. What's the slope of the vertical asymptote? So it doesn't exist. We saw this earlier in the semester with rational functions. Anytime you have a denominator, we've got to check if the denominator becomes 0. If it becomes 0, then we have a problem. I'll use the easy ones. So tangent pi over 4 plus 2 pi, tangent pi over 4 plus 4 pi, tangent pi over 4 plus 64 pi. Here, pi. Three pi. $17 pi, and tell me what you get. Okay, so tangent pi over 4 plus 2 pi. Well, if you start here, full revolution, get back there, it is going to be 1. If you just did half a revolution, well, would tangent pi over 4 plus pi 9? Yes, it is tangent pi over 4, but that was 9 for the block. In other words, which quadrant? Third quadrant. So you start here and complete 180 degrees, you'll be right over there. We know from last time in the third quadrant, tangent is always positive, and whatever pi over 4 value you have, you're going to get the exact same number. 2 pi, so full revolution, another half revolution, so 1 full revolution, 2 pi, half a revolution, pi, which would be 3 pi, you're adding pi over 4 to it, you're back over there, yes, still 1. 2 revolutions, 4 pi, 1, 2, back where you started, you get 1, same there, same there. Based on that, what is the period of tangent? So if you go 1 half revolution, which is pi, and add pi over 4 back here, so that is 1 million. What is the period? 5. So the sine function is 2 pi periodic, cosine 2 pi periodic, tangent is pi periodic. Good. Yes, okay. So we can find the reciprocal of sine, cosine, tangent. So reciprocal would mean 1 over what's the half. So if we did 1 over sine t, it's pronounced as cosecant. Similar manner, 1 over cosine t. Secant. One over tangent of t. No tangent. From last time, what is the domain of sine t? So, if I simply look at 0 to 2 pi, cosecant will also exist, except at what values? Sine 0 is 0. That's going to be a problem, because the denominator will become 0. What other value for t is going to cause problems? So denominator becomes 0. Or what other value of t does sine become 0? You can look at the unit there. Fine. So 0 is a problem. Pi is a problem. Any other values? 2 pi. So that would mean you're completing a revolution. So should I include 0 in the domain? No. What value should I go up to? Pi. Can't include pi, so pi to 2 pi. For now, I'm just going to stick with 2 pi interval 0 to 2 pi, one revolution. Later, we can extend it than the 2 points. So what should I put in the middle? Unit. What about the range? -1 to +1. Why did you say negative 1 to +1? Just go ahead.
Because that's the range of the sine function.
That is the range of the sine function. That's what we will think. So range of sine function is -1 to 1. So 1 over sine has to be from -1 to 1. That's what one would think. Let's pick a value, pick up your calculator and plug in tangent, excuse me, not tangent, 1 over sine 0.95 pi. What do we get when you plugged in 0.95 pi for cosine? 6.39. Clearly, it is exceeding 1. Plug in 1.75 pi. So cosecant is 1 over sine. Your calculator doesn't have cosecant directly, so you have to do 1 over sine 1.75 pi. -1.41. And it went below -1. Can someone tell me why we are getting values exceeding 1 and going below -1? What do you mean by longer?
Has a wider range than -1.
That's why. So, Peter is correct, that's a wider range. Reason being, we have an asymptote, correct? So, when anytime we have an asymptote, specifically a vertical asymptote, it's going up toward positive infinity, and it has to go along a line toward negative infinity. So, which is why we are getting values over 1 and below -1. The range here is negative infinity, positive infinity. What about cosine? Excuse me, secant t. Or what value of t with cosine be 0? Pi over 2 and 3 pi over 2. Again, I'm simply looking at 1 revolution, 0 to 2 pi. Could I include 0 in this case? Alexis says yes. Why? Cosine 0 is 1, so not problem 0. And what about pi over 2? No. Cosine pi over 2 is 0, so 1 over 0 you get infinity. The next time it would become 0 is at 3 pi over 2. Do we agree? Cosine 3 pi over 2 is 0. But there is a gap between pi over 2 and 3 pi over 2. Yes. Does it exist in that interval? I erased the unit circle. Between pi over 2 and 3 pi over 2, you are going to get a negative number. pi over 2 is up there, yes. 3 pi over 2 down there. So it would include quadrants 2 and 3. And we know in quadrants 2 and 3, cosine is negative. It does exist, so we can't get rid of pi over 2 and 3 pi over 2. Zero to pi over 2 can't include pi over 2 union. I can't include pi over 2. I can't include 3 pi over 2. And things in the middle would work. So union 3 pi over 2. Can I include 2 pi? Yes. And cosine of 2 pi is 1. But what about the range? We're not including pi over 2 and 3 pi over 2 because the denominator would be 0. In other words, we will have vertical asymptotes similar to cosine t. So what is the range of secant t? Negative infinity to infinity. For what values would a tangent become 0? Could I plug in? Well, tangent is sine over cosine, which would mean cotangent is cosine over sine, the reciprocal of tangent. So here we would have cosine of t divided by sine of t. So for what values would sine of t be equal to 0? 0 and pi. So it is going to exist for all values between 0 and pi. You may ask, well, what about pi over 2? Well, sine pi over 2 is 1. Cosine pi over 2 is 0. 0 divided by 1, possible. So can I include 0? Maybe. Okay, why don't you put 1 over the tangent of 0, and let's see if you change your answer from maybe to no. Let's just say no. What about you, Brian? Are we going to change from maybe to no?
No.
Oh, you're not going to change? Or you are going to change? Okay. Doesn't make sense. So we can't include 0, so open parentheses. What about pi? No. And union. I can't put cosine pi. I just can't do sine pi. So pi all the way up to should I include 2 pi? No. What about the range? It's got vertical asymptote, so we would say negative infinity. Okay, now that we saw periodicity in the previous case earlier, based on what we know about the periods of sine and cosine, can you tell me of sine, cosine, and tangent? Can you tell me the periods of cosecant? Is it 2 pi period or is it pi period? Cosecant. Why pi? Okay, 1 over sine pi over 4, evaluate that, and add pi to it, that will bring it to 5 pi over 4. So I want you to evaluate sine pi over 4, and then divide, or 1 over sine pi over 4, 1 over sine 5 pi over 4, which is half period, then you're adding pi. What value do you get? Are they the same? No. So easy way to remember. If something is repeating a period of 2 pi and you divide, and you divide 1 by a function that is, or that has 2 pi period, cosecant will also have the same periodicity. So cosecant, 2 pi periodic, secant, same, since cosine is 2 pi periodic, cosecant, 2 pi periodic. What about tangent? Excuse me, cotangent. Pi periodic. Why? Tangent repeats itself with a period of pi, which means you do 1 over tangent, that has to repeat itself with the same period, which is pi. Are we clear? Yes.
What I was trying to ask was, sine to the negative 1 power is equal to cosecant, right?
That's where we're